All right. Hey, everyone. Let's get started with the radLab tonight since it is just a little past 8. Hopefully everyone is here, but we have a few stragglers joining in afterwards. So before I get going with these slides, and before I tell you even a little bit about myself, I want to preface this all with some major credits to people who have developed these, a lot of these slides, these visualizations, as well as the software behind them. So first off, these slides are built with Reveal.js and utilize Pablo Tamarit's code for using D3 and D2 transitions. So basically these are HTML slides. This is just a web page. So if I actually pull it down, this looks like this. That being said, almost all of this is web-based graphics. So as we think about, as you see everything here, think about it in terms of your knowledge of the web. So if it's HTML, if it's CSS, if it's JavaScript, think about how you would build something like this. And we're going to talk through some fancier visualizations as we go later. And with that, I should give a major credit to Nadia Bremer, whose GitHub is here in Bremer, which is misspelled as it goes. Let me quickly drop this link into the chat, and hopefully everyone else can check it out. Her slides that go similar with this. So her GitHub is there, and let me send you a link to the slides for tonight as well. Make sure they are working. They are hosted on GitHub, which is then again one of the other cool features of this is that all the code is doubly available. So it's both available in the repo as well as you can see it very quickly. So check out, this is actually not the most up-to-date, but I will update everything before the night's over. So check out, as well as those of you who are more interested and where a lot of these visualizations come from. Like I was saying before, most of the visualizations, if they don't have credit, probably come from Nadia or a modification of Nadia or Mike Bostock's work, mostly because they are the absolute best for finding examples of D3. So here are Nadia's slides, which are what I borrowed this template from and a ton of these visualizations from. Okay, so with that being said, let's get into some slides. So what I want to talk about tonight is data storytelling. But before I get into data storytelling, I want to talk to you a little bit about myself. I am a second-year student in the quantitative and computational biology program at Princeton. And I have very little artistic ability, but a little bit more web development ability. And with that being said, I wanted to take tonight and talk a little bit about the different ways that we get at data. So first off, what is boring data? And why do we want to avoid that? And when is it good? So being in the computational biology program and being a little bit of a behaviorist and a geneticist, this is the type of data that I'm used to looking at. Well, the prettiest picture I had around, rather. So these are a bunch of flies. We have a camera facing overhead. And if you can see them here, we can zoom in. And we can see that we have little tracking points on each fly. So we have tons of data. And being the scientist I am, I want to visualize this. I want to get an idea of how do we do comparisons, how do we do statistics, and what this almost inevitably leads to is me making graphs that are boring. So I almost always end up making a graphics, stat stuff that look like this. We have density plots. We have kernel density estimates here. We have bar plots. We have box plots. We have all of the things that you see in your introductory stats class, and you say, okay, this is boring. They get the message across, and when it comes to science, I think these are great. I think, in example, understanding that there's biases in a distribution, like in the top left here, you can see these peaks and you can see them transition away. If you're looking to see, say, a p-value, something like this gives you a very easy visual comparison. The same with the rest of these figures. They let you compare the data points very easily, but what they don't do is tell a compelling story. So that's what I want to talk about tonight, and that is, how do we tell a compelling story? And what are the tools that we have to do it? So starting off, let's look at the basics of how we can get to some level of interactivity and some level of clarity and practicality of getting at data. So an example, something like this. So this graph is actually just you can think of it like a correlation matrix. It's actually the relatedness of a bunch of flies that I showed before. But all you really need to know is that this is one of the ways that this is like a step beyond the flat box plots, bar plots. So this gives us the ability to look back and say, okay, what is the actual number in here? Okay. The issue is, of course, we don't normally care about that. We're normally interested in trends. And so that's where the rest of this presentation is going to go. So I want to talk to you about how we visualize trends and how we make compelling data stories. So the first thing that we need to have in our toolbox to do this is the basics of web frameworks. So I'm not going to assume anyone is familiar with JavaScript or HTML or what I would call the basics of the web. And with that, I want to go back and say, how do we draw graphics in the web? So the basics of how we would do it would be using something like this. So scalable vector graphics, SVGs. So the rest of this presentation is going to be based off of using D3.js, which is a way for us to integrate our data into these shapes. So these shapes, be it a line, be it a circle, be it a text box, be it some kind of radial, allow us to integrate some kind of data. So be it traffic data, be it birth rates, be it temperature. Let's just integrate this and then use that data to build graphics. So that is the building blocks of most of the browser-based graphics that we use. So if you've seen New York Times COVID displays, if you have seen the Wall Street Journal tell you about human trafficking, if you've seen the presidential election forecast, almost all of these are built up from something like D3.js. Even the tools like Plotly, which I made the matrix graphic before with, is just like that. So the question being, what can we make with D3.js? So I'm going to start off with pretty examples and then kind of fall backwards to things that are feasible for the average person to make. So first off, a million examples. This is actually a modified version of the example setup they give on D3's website. And we can, of course, follow any of these and see some extremely cool displays. So for example, let's take countries by area. You take countries by area, highlight, see that everything is split up into its own vector graphic. See, these are all derived from paths. We could also take a step back and go, let's take another one. It's a good example one. With bubble charts. But the point being, like, there are all kinds of crazy graphics. And if you're more interested in these, it is easy to follow along with them in the slides, and you can just double click on them from the slides that I posted in the chat. Okay. So with that, let's talk about one of my favorite ones. That is the Nyc Food Reverse. So if you're interested in understanding inspection data, Foursquare ratings, and you don't want to go through Foursquare or something boring like Google Maps to understand restaurants, you can, of course, use D3 to visualize it. So say you're interested in something like total number of violations of some health code by restaurants. So in the example, sanitation problem category 04H which is the raw, cooked, or prepared food, is adulterated, contaminated, cross-contaminated, or not discarded in accordance with HACCP plan. There are 1,929 restaurants that fall in this category in New York. And of course, we could do that for any of these. So they built up this beautiful website as a network, all based on D3. Well, as well as Mapbox and a few other things to get us here. So, of course, again, integration with spatial data. We can go here and say, well, what does this distribution look like spatially? We can also say, well, I want a better version of Google Maps. I want something that I can actually get a complete interaction on a single page, whereas Google Maps forces you to use a list box or to not directly interact. This we can go and say, okay, we have all the circles we talked about before, hover on them, see our location, or a link to a restaurant, sanitation inspection information, and so forth. The point being, you can build scalable web designs with this. But again, this is crazy and insane for somebody like me who doesn't really know what they're doing. That being said, I can definitely take examples and make reasonable information. So in this example, it is modified from Mike Bostock's weather radial and some data from OAA. We can look at, well, what does the temperature look like across a given year? With the top here being January, and the next figure I will show you will be a better version of this from Nadia Bremer. So in this case, we're interested in not hard information like I was trying to show in the beginning with my fly data, but rather trend information. So here you can see that this is San Francisco weather. I think the point that this graph gets across is that we should all move to San Francisco, and that's mostly it. It's hard to interpret this. It's hard to get far beyond saying that San Francisco has a pretty static temperature. It's very nice. But we can also do better than this. So Nadia Bremer took these kind of radial displays and has made things like this. So question being, can we make the weather radial better? Where in this case, these are the highest to lowest temperature of each day, January all the way back around to December, where we have, it is colored by the median temperature of the day, and we could see, well, I really do like New York City, but when it comes to weather, San Francisco is looking a little bit nicer. But again, we have a lot of different ways to visualize this, all pulling directly from a data set within your browser. So this isn't, in this case, it's a static visualization, but there's nothing keeping it there. If we were to go into this page and actually inspect it with developer tools, you would see that these are all individual objects, and they can all be manipulated directly through JavaScript. So how do we do something like this? Again, with credit to Nadia Bremer, as with most of these slides, let's talk about the basics of how we would build something with these scalable vector graphics. So assuming that you are somewhat familiar with the basics of web development, we know that we have a nested document object model, so a DOM, and that we can access each of the elements in a given DOM. So we have divs, we have a bunch of anchors, we have spans, we have everything else. So in this case, let's use D3 to give us a simple gradient and see if we can go from there to something that's meaningful. So here we append defs, so definitions with unique IDs that we can later reference. So in this case, we take two colors. I do a gray palette. And to make a linear gradient, I take my location, I take x1, y1, x2, y2, and I go ahead and I make a gradient. So D3 has all this baked in. All you have to do is append their element called linear gradient, set it to 0, 0, 100, and we could do everything in between. We could also do multiple colors and a lot of other different methods to give us a pretty gradient across colors. Being a scientist, I want two colors, and many people would argue that they're far from the best colors, but in this case I did gray. So I said let's do this. Let's make a color stop with color 1, another color stop with color 2, and then apply gradient to the whole thing. That is after appending a rectangle. Like we talked about before with SVGs, rectangles and circles and lines are the heart of this. So we create a rectangle, we append a linear gradient, and we go from there. Okay? So what's the next step from here? We know how to make gradients. We know how to, we know that there's some amorphous method for integrating data into this. So let's go a step further. So a step further puts us in heat map territory. So kind of like I showed before, except with a little more pizzazz. So here we have number of accidents in the Netherlands, again, based on Nadia Bremer's data and Miles McLaughlin's heat map block design. We have on the y-axis, day of the week. On the x-axis, we have the time of day, and we can see that almost all accidents occur at 7 or 8 a.m. or 4 or 5 p.m. as you're coming to and from work. Not all that surprising, but I think this is a much more compelling graph than what I showed you at the beginning of this like solid block of information. You can, of course, step backwards, and if we wanted to change up the gradient, we could do this a lot better as well to give us more compelling or stronger emphasis on the places where we have higher accident rates. Okay, so let's take it a step further. So clearly, if we can integrate data into our browsers, then we can also use JavaScript to manipulate this. So another Nadia Bremer graphic of the Hertzsprung-Russell diagram, which is actually showing us luminosity against temperature. But if you notice that the temperature is the reverse of what you would expect, where the hotter is further to the left, we can see that there's this beautiful main sequence up the center. Almost all stars lie, as well as the giants are in the upper center and upper right-hand corner, and then the rest of it I will not claim to understand. But one of the reasons I really like this visualization from Nadia is that we can actually see the interaction of the sizes. So all of these are colored based upon planetary features. So they're all have their own unique coloration pattern. And they're also scaled to be interpretable. So if we were to take these and set them to their true scale, this graph would look like this. So that's, of course, uninterpretable. So we'll take a step back and say, okay, let's make it interpretable and say, okay, our sun sits here, and we can continue to hopefully interpret something from this graphic. So I think this is both compelling as well as clear. Okay, so that's another example of things you can do in a D3. Working our way up from gradients all the way to scatter plots with gradients in the circles. Okay, so again, another Nadia Bremer plot, because again, I just think she is truly amazing. This is a graph of the 10 most popular girl names since 1880. Of course, when we're working with something like a gradient, or when we're working with data like this, we can't actually look at the whole thing at one time. We want to be able to split this up. So in the way we talked about color gradients in the past, so here we used stop colors. We can actually use multiples of stop colors to give us these harsh transitions. So in the case of this, we have a little bit of D3 magic from Nadia's part to make this transition from gray to colored. So it is simply a stop color here, a start color, and then another stop color and another start color. D3 also lets us interact with it so that we can drag it along and say, well, let's see as much of the data as we want, as well as make it clear what portion of the data you're looking at without giving you cluttered legends and inundating you with information. Okay. So again, I think this is a great visualization. And again, it focuses on this idea of getting across trends and compelling data rather than simply talking about the fact that that you can do statistics on data. Okay, so like I was saying, we have gray stops, colored stops, gray stop, and back edit. JavaScript already has a lot built in for doing this dragging function, and let's just immediately go to what we're looking for. And again, with the rise and some would argue fall jQuery, we saw this ability to go back and forth. Okay, so what this looks like in code is here, is on brush, set our actual points. So see it update in real time, go from there. So these kind of thresholds are great for all kinds of things. So in example here, we have 3 categories of body mass index. So we have both normal weight, overweight, and obese. And we feed in our data to this, which is, I don't think I actually have the data in this slide, but it's just a flat JSON file, and we go from here. So again, we have these thresholds of, say, we have 1 to gray, 1 to orange, 1 to red. And the cool thing about SVGs is that they're not directly related to your data. So we can feed in, if we do it by men, we can feed in women and simply transition our way around. That being said, we could do all kinds of other plots. So we can do Sankey diagrams. We can do circular Sankeys. Again, credit to Nadia for building these up. I think they're great visuals. And I also think that they are very useful for getting across points without drawing a million Sankeys in the same way that everyone does a job hunt diagram. But again, one of the things D3 affords us is the ability to do this. So the ability to keep the data in this same format and then call 1 or 2 functions to get it to transition it to this. So in this case, we used a chords function, and we can transition it to being circular. We can also flip things as we go. So we can adjust our data and do smooth transitions. Here's an example of that in practice. Again, we can look at, like, say, education occupation, the same that you would look at with a job hunt or something of the sorts. Okay. Another thing that we can do with SVGs and D3 is filters. So an example, take a filter, append an ID, append it to a location, and then go do whatever magic you would like with filters. D3 has a ton, and there are tons of libraries out there for us to continue to expand it. With that being said, we can use these filters to do a lot of crazy graphics. So in this case, we're using a blurring filter, where the faster these circles are moving, the faster they're blurred, or rather, the more they are blurred. So even though it's not obvious, it does sort of make this more human. It makes it more intuitive. It makes it more compelling. So again, motion blur filter code. This is from Lucas Bever's SVG modal demo, as well as, again, some of Nadia's modifications here. So we can see, what does it look like without motion blur, which probably isn't good over a stream, I imagine. But, now let's add motion blur. Now, let's take a look at another filter that we can apply. This one is a bit magic to me. I still don't exactly understand how it works. It's called GUI, and it simply makes this absorb effect that you see. I should have another example. So an example, something like this. So not only does it give this merge effect, it also deals with the gradients of color that are applied to each element. So these elements can be taken, I think a good way to describe it is this is a fire and forget method for giving you some more fun graphics. So in an example of doing it, again with Nyc Bremer's visualization of what would we do if we wanted to do a pretty visualization of the 150 largest cities in the world. Well, let's use GUI. This graphic, I think, is a great place to explain that these visuals aren't free. When you're trying to do something like this, it is extremely computationally intensive if you are not careful. It's like this. It's lagging on my screen, and I presume it's even worse on the stream. But it still gives you a very cool effect. And when you have the computational power to deal with it, and you're doing it all in browser, it makes for a beautiful message. Again, with another example of interacting with objects. So something like these circles, we can have a repel effect on your mouse. So as you would hover over an item in a normal web page, we can make the graphics interact with this. We can also make this GUI and basically see my computer crash. Let me get off this section, hopefully, before everything dies. And then finally, an example directly from Sketch.js's particle demo and the final sections of Nadia's example, the most beautiful particle demo ever. I think as far as pretty graphics, this is about as good as it gets. This, of course, is not meaningful graphics. It's rather just pretty graphics. But I think there's a lot to that as well. So I think that's most of what I wanted to get across tonight is this idea of what are the basic tools that we need to make data-driven documents, and where can we find ourselves with current web technology to be both informative but also compelling. It's very easy, again, for me as being in the sciences to make a bar chart, to make a box plot. But I don't think that's always compelling. I think it requires too much background knowledge and or understanding to get far from here. That being, again, with that, thank you. If you have any questions about D3 or SVGs or building up data visualization or other crazy topics, like if you want to talk about fly behavior or genetics, I would be more than happy to talk about them. I'm going to hang out in the Slack for a while. So let me know if you have any questions. And I think that's it for tonight.